Very good morning to students. Today we are going to learn about auxiliary ventilation system in the part of the mine environmental engineering subject. It's one type of air distribution in long headings, drifts. This is a very important for the actual the ventilation network design and booster fans installations. Well, this is a view of open cast mine, the mine model. This is an underground gas identification procedure particularly in the quantity and quality survey purpose. Well, today topic is a minor environmental engineering subject, auxiliary ventilation. Auxiliary ventilation has a 50 minutes duration. Coming to the auxiliary ventilation, it's not main ventilation, it's a part inside the ventilation system. Ventilation in coal mine development phases and tunnel and drifts is a majorly auxiliary ventilation system is using. So the basic definition was given here. It tunnels or drift. Tunnels or drifts are essentially blind headings till they are connected to shafts or adits. This poses real challenges to ventilation engineers. The workplace environment in the tunnels is greatly influenced by the ventilation method. Selection of proper fan and duct apart from the cost of ventilation. So tunnels and drifts are essential blind headings. Why? Because tunnel serve is a continuous passage of from ending to ending. There is adit is also one of same thing is using. Similarly, blind headings. This is also one of which is particularly in a long wall panel systems. So such things, air cannot be passage in effectively. That the real challenge to ventilation engineers has to maintain the sufficient quantity to the tunnels and also shafts. The workplace environment is greatly influenced by the ventilation method. Selection of proper fan, that is very important. Selection of the fan is very important, and duct apart from the cost of the ventilation. So this is a which major part of the auxiliary ventilation is concerned. So what are the ventilation in tunnels and drifts mainly done by uh, practice cloth. There is a one unique methodology, and another is the auxiliary fan and ducts. These two methods we are applying for the getting the effective ventilation system in the blind headings. Practice cloth. Uh, Practice cloth. This is as simple as a sheet or a sheet of a canvas commonly made out of treated Hessian cloth, nailed on proper placed at 1 to 1.5 interval along the heading to prevent the short circuit of air from the intake to return. So, causing the ventilation air to reach the faces, it may be used. This is actually British cloth is used, for example, any gallery. You divide into two parts and nail to the roof. That is a one, and as a screen across the airway to prevent or reduce the flow of air along it. As a partition along the roadway to divide it, in two parts, in intake or return. Conditions of using line practices. Bracket cloth coated with PVC is impermeable to airflow and is more suitable for line practice to ventilate a heading. This can be used only for a short distance, not more than 20-meter long, into the heading due to the heavy air leakage. The intake side of the bratis should be kept wider than its return side. The wide intake will help to circulate adequate quantity of fresh and cool air for the miners at the face, as well as will facilitate easy movement of the man and material through it. So that is the basic conditions of line practice is concerned. The cloth made for the PVC in the implement airflow and is more suitable for that's to ventilating the headings, particularly showing here. This is a actual figure. Here we can observe. This is the Bratis cloth. This picture is a complete representative of the Bratis plus erection. The line Bratis used for auxiliary ventilation system. So please read and you can redraw it in our notebooks. This is one heading. It will intake air is coming like this. So the written has to go like. So for ventilating heading, the air current can't go to the beyond 5 meters for this heading. In such condition, you have to force ventilation. You have to divert by artificial line practice PVC claw. This will be erection from the by in middle of there will be provisions against wall, roof to bottom. So it's showing the temporary partition. So air force air going and ventilating where the persons are working there, what are the workers are going on, and that air will be automatically returned to them. So this is another one. But in case some forced and exhaust systems you are using, as usual, such conditions, such cases, in case of force, in case of forcing, uh, air is going and ventilated here and going out. The exhaust case, air is going recirculated here and coming outside. So these are the difference between the force and exhaust system of auxiliary ventilation with the line that is used. And then uh, there is a another method. This is called as a ventilation headings by line batteries. Similarly, showing here for intake airway and ventilated. Here is the line practice separation is there. They ventilated going another heading and going outside, and also the ventilated other heading going outside. Return. This is another model of ventilation headings by the line practice. And then auxiliary ventilation can be following types. They are forcing, exhausting, overlapping, and reversal. So these are the general classifications of the auxiliary ventilation. Can be type forced, exhaust, overlap, reversible. Because there is a problem is you can be see here. For example, only force is using. What happened? Your rising of the dust is more here. There may be recirculation. If the exhaust is using, some air will coming not to going to sufficient. So combination is also very important. Combination of forced and combined with exhaust, or exhaust is the main combination with forcing also. This is between the experiences of the heading length and also not prevent the recirculations. Uh, this will be can be achieved. Then here also I'm showing here one beautiful figure. It's a beautiful picture of auxiliary ventilation system with the forcing ventilation with the tube. So this is the forcing. The air is forced to going inside. So this is one. The return. The exhaust ventilation with the tube is exhausting. It is extra exhausting air. Another one is the ventilation of heading with a forced fan F. Ventilation of heading with a forced fan F. Here is a fan is the location is given. The air is going inside up to the heading part. The duct they are using. Instead of line, there will be leakages. The problem is there. For example, you see here, this is the line bratis. But if air is going, but the leakages problem, the sufficient air not going there. There may be contamination. This is problem is there. Return area also contaminated here. So here is going and return to here. So this air will be contaminated air. So in such case, the purity of air is not expected. To go through the fan duct, this is a flexible to 4.1 meter away from the return. So the fresh air will be pushed to up to the face. And also similarly exhaust system also. This is also an exhaust system. Similarly, it work as exhaust fan. Here is a fan is in forced nature. And then overlapping. As per the heading is going advancing. There may be problem with the single force and a single exhaust, so that they are using a combination overlap system of ventilation of headings, forcing fan and exhausting fan. So this is overlapping system of ventilation of headings. This force is applied here, some middle of the heading, so that fresh air can be expected for men. And all same time, the foil gases, what are they raised there due to the blastings or advancing or methane, so that may also extracted and entering to the return air. This is one model. This is another one, reversal system of ventilation of heading with two fans, forcing fan, the exhausting fan. This is a suction. There is a two forcing here using. This is going inside, and also the same. The fan will be served as a exhausting system also. This is the reversal type. The doors are erected here. That can be then this is very clearly showing here. One more model. model. Here is a, so this is a return, so reversal system of ventilation of headings with single force fan. Exhaust ventilation of phase worked by a boring type mission. Boring type mission. Uh, uh, for example, because headings are made by the not drilling and blasting method, they may be advanced to speed up activity. AM50s, road headers are working there. Different model, continuous miners also sometimes they're using that, so long headings can use. So particularly road headers, they may be boom type or square type ball type cutters. So when the explosives and drilling is not winning, at that time, more dust can be expected rising there. So such case, boring type missions, armored flexible ducting is there, filter fan is there, the air sucked and that return connecting to the duct into the return airway. This is one model. And another model is also there, the overlapping system of ventilation for a heading with a continuous miner system. When the continuous miner system is working, so these are the two important. Presently, most of the mines are in mechanized system to speed up of activity. In such occasions, you have to provide the good environment conditions in the mine, the operator as well as those who are working in the. So this is a unique operations concern. Further, going to some literature on the auxiliary ventilation system. The efficiency of most of the auxiliary ventilation system depends more on the proper choice of a duct than the ventilator. The efficiency of most of the auxiliary ventilation system depends more on the proper choice of the duct than the ventilator. This is a very important. The auxiliary ventilation mostly the above figures you observed, above sketches. Every operation is a efficiency depending on the tube. This is a tube. This is called as a duct. This is the duct. They have the say, specified diameter, and also the material. Also, some of the flexibility is there. Some of the fixed iron type of material also using. So that efficiency, the efficiency of most auxiliary ventilation system depends on the proper choice of the duct than the ventilator. Duct have low coefficient resistance. So this is one also very important. We see the loss of the air friction in mine. There is a lot of frictions are encountered due to the while traveling the airway. Most of the work environment is there. Haul edges are working, signaling balance are there, props are there, shocks are there, not in uniform in nature. So these are the very challenge for the for air is concerned, resistance is concerned. So such thing you have to duct have less coefficient of friction. So that is advantages. As square by A that our pressure dropping the formula is concerned. So coefficient of friction when the resistance is less. So automatically the value of the pressure will be more to reach the quantity at end point of the mine workings. If the length of the is more, the resistance will be more that requires more fan pressure to overcome the frictional pressure loss. High pressure leads to the excessive leakage. New rigid steel ducts, if properly joined and aligned, have a coefficient of friction within the limit. PVC, a coated flexible ducting, when the properly infiltrated, have fairly low coefficient of the friction up to the 0.02 Newton seconds per meter square for PVC are using. The resistance can be reduced by having large diameter ducts, but such ducts become costly, more difficult to carry and install and take up a large space, which is a undesirable in headings of the small cross-sectional areas. So this is also one advantage of the PVC coated one. Those the choice of proper size of the duct consumable with the length is essential. According to NCB UK and other countries, use of 450 diameter ducts up to the distance 900 meter beyond, which the duct should be of 600 In India, however, a wide range of duct size varying from the 300 to 800 are used. So this is the about the material using our duct are also the influencing factor for the efficient successful ventilation system is a basic purpose of why you are ducting using. This explanation, I hope that you understand the purpose of the ducts. Now I go to the Bratis. There is the types of ducts. There is the two basic the fixed ducts are there. So convenient. The more distance is moving, so the fixed ducts are some transportation difficulties there. Some challenges are there that we'll discuss here. This slide. Well, coming to this one, two type of ducts are commonly used: the flexible ducts and the rigid ducts. Flexible ducts. Flexible ducting is a much easier to store, transport, and install the rigid ducting. So flexible ducting means it is just like a spring type. It can be comfortably come to the low space. If required, it can be spread it just like plastic rubber. If you want, you can be enlarged. If not required, just like most of the wash machines, they are using waste pipe. Like similarly, if not required, you can be fold it. Automatically, it will be come to top. So that is one thing. Without required, you can be folded. Straight away you can put it to the hole. So or otherwise, the compared to rigid is a it is a metal not concise. The surface to bring to the underground to the particular headings and installation to the wall corners. It may be some the weight also more some compared to the uh, flexible ductings concern. They are cheaper in initial cost, but have a shorter life. They are cheaper in initial cost, but have a shorter life. Earlier, flexible duct was made from rubberized cotton fabric, but this material was inflammable and was easily torn. Now, flexible ducting may be made from the terling, rayon, or nylon coated with PVC. Flexible canvas or PVC coated ducting incorporation wire armed embedded in the fabric is now available for the exhaust ventilation. They are conveniently used in shorter headings up to the distance of 300 meters, where a more permanent steel duct become unnecessary or at the face end of the rigid duct, where they can easily removed at the time of blasting. Flexible duct are very suitable in curved headings. So that's very also very advantage here, showing that where whenever turns are there, so we can be see here it will be possible. So here the fixed duct, rigid duct cannot be possible to turn because of it may be full cracks gap in leakage is problem. That means flexible duct we can be flex anytime, just like waste pipe in the wash machines. So flexible duct are more made a longer section those reducing the number of joints and consequently leakages also. So this is a more advantage of the flexible duct is concerned. And rigid ducts. Two type of two types of ducts are commonly used: the flexible ducts and rigid ducts. Rigid ducts of the round sections are commonly used for all permanent installations. They can be made of steel, aluminum, plywood, fiberglass, reinforced plastics, or high density polythene. Aluminum ducts are light, have a smooth internal finishing, resulting in low coefficient of the friction and as well as easy to transport, but they have not found common use in mines as they are costly and are easily damaged and D-shaped. Steel ducts are commonly used in every mines and tunnels as a permanent because of their sturdiness and long life. Fiberglass reinforced plastics or high density polythene ducts can also be used in the where in the air in high corrosive nature. So that is also one advantage. Steel ducts are usually made of the hot rolled milled steel sheets of 1.5 1.6 mm thickness, 30 to 75 centimeters in diameter and 2 to 4 meters in length. Different sections are joined by the bolts, something you can be joined that one. So this is some more advantage of the rigid also because of rugged nature. If flexible is a fiber made, if any irons or something heated, that will be leakages problem. But the repairing also problem. So even a rigid iron sheet can be welded by the welding machines also. This possibility is there because made with iron sheets. So these are the about the ducts. So these are the rigid and flexible depending upon our convenience, our depending upon our um, suitability to our mind condition. You can go. So once again, I am repeating the what is the definition. So overall, once a method of supplementing the main ventilating current in a mine by using a small fan to draw air from the main current and force it through canvas or metal pipe to some particular place, such as the ends of the drifts, crosscut, rises, entries, or other working driven in a mine. So this is a very essential thing, sir. The auxiliary ventilation means method of supplementing the main ventilating current in a mine by using small fan to draw air from the main current and air for force it through canvas or metal pipes to some particular place, such as the ends of drift, crosscuts, rises, entries, or other working driven in mine. This is important. And coming to the once again, what are the you are observed in above slides? That's I am going to literature way explaining. In a above figure, you see there's so many complex cities that we will explain with the some literatures. In underground mine, sometimes ventilation will be insufficient in some districts or part of the mine. In such situation, ventilation can be improved by means of auxiliary ventilation. The auxiliary ventilation is possible by use of auxiliary fan and booster fan. The location of booster fan and auxiliary fan are important to improve the ventilation. So in underground mine, sometimes ventilation will be insufficient some districts and part of the mine. So that is the main cause. So when improving the auxiliary through by auxiliary ventilation with the help of a fan, the location of booster fan is installed. So the improving the ventilation. Auxiliary ventilation system is an arrangement. This auxiliary ventilation system is an arrangement to improve the quantity of air one or more district having high resistance
without increasing the total quantity of air circulation. That is very important. Where the high resistance is there, to increasing without quantity of the air circulation by from main surface fan within the air, we suck that. This is possible by using another auxiliary fan at the underground workings. So auxiliary ventilation system is the means of ventilation used below ground wholly or mainly for ventilating one or other of the following: long headings and cross measures drifts driven in advance of the workings, narrow places in mechanized room and pillar working, roadways being drawn off after collapse of the roof has blocked the normal air course. This is an auxiliary to main ventilation system of the mine. So this is about the basic concept of the purpose of serving, particularly long headings, cross measure drifts, narrow places, particularly mechanized room and pillar working, roadway driven after collapse of roof blocked. So normally air course is not possible. Such conditions. So these are the situations you are in. Not only the simple machine is working out, this is also very important for auxiliary ventilation establishment purpose. Yes. The roadway, there is a roadway is blocked. So such condition also you can apply. Fresh air can be sending. Just like so most of the boreholes, children are falling down. But we are using a small pipes are inserting and apply the small pressure. But auxiliary also same purpose is serving. Even Chile accidents also 300 meters depth. They're sending the small shaft and applying the air supply to those who are leaving 13 persons in the buried accidentally uh, closed down all the ways. So such kind of same similarly we can use pipe type auxiliary. This is also called auxiliary. Four system of auxiliary ventilations are used in mines, namely forcing or bowling system, exhaust system, combined blower and exhaust system, reverser. Each system has its own advantage and disadvantages. The condition required for auxiliary ventilation system. What are the conditions? The following are the different conditions required the auxiliary ventilation. Where there is no proper main ventilation to the part of the mine, like long headings and cross measure drifts driven in advance of the workings, narrow places in mechanized room and pillar workings, roadway being drawn off after collapse of the roof has blocked the normal air course. So this is a one type of conditions where the auxiliary ventilation you have to implement. So this is first part is a there's a no proper ventilation, long headings, narrow mechanism room flares, whenever drawn off the collapsing of the situation is there. Right. This is the already I am showing the line type. Most of um, one is a air tube. This is nothing but a flexible iron. This is a heading. One is a heading. This is the heading. Forcing fan you are using here. This is the third is a forcing fan is applied here. The air is taken from the fresh air. And, it is not contaminating the return airway because this is also return airway for also they are using for traveling purpose. But fresh air will be comfortable to the where the face the person's working. This is a simple forcing or blowing system. Then with this system, the air is carried inside the duct to the face of the heading. It is therefore cannot pick up moisture or duct on its journey to the face, and it arrives in a clean, dry condition. The method is therefore particularly suitable for wet headings where the rock atmosphere is high. So this is also one advantage. If rock atmosphere is more, what are the air will going? It will be taken the auto radiation. Air will be hotter. So duct will be advantage. Picking up the moisture is also less. So during the area in clean dry condition, the method is there for particular suitable for wet heading where the rock temperature is high. So this also one advantage. The air cannot be mm, quality air. You can be sent the quality air to the person. That is the purpose. The solving for the ducking method. The high-speed jet air leaving the end of the duct has a good scoring effect at the face of the heading for the efficient removal of dust, noxious gases, and fumes of explosives. But it also often causes series of discomfortable to the workmen at heading face. Advantages. The advantage of forcing ventilation is that because the fan hands handle intake air, an electric motor can is safely mounted in the air stream, and this result in a compact fan unit. It's take little more room than the dock in which it is installed. What are the disadvantages? Duck is a fumes after short firing passes every slowly out of the heading. In a long heading, maybe some hour before they are complete clear, and during this time, man will often passing through them. This problem has become more serious during the recent years. So very nice, very drastic problem. If anything is fire is happening, start firing. So repairing work is taking more time because of long heading. Due to the increasing weight of explosive, which is a busy is each round of the shots, and the greater frequent shot firing, which has come with a high rate of dry wages. So this is the one model of exhaust system. You can observe here. So from here is a intake is coming and ventilated to one is a air tube heading exhaust fan. Um, So intake air will be not contaminated with the return air. If we connect it here, the automatically with this recirculate. So simply they put into another gallery starting and thrown out into the return. Next, exhaust system. The heading in this case is used as a intake and the air tube or duct as a return. The fan itself is placed not in the return, but in the intake, the air being delivered into the return through stopping. The electric motor may those be safely used for driving the fan. Advantages. The main advantage of or exhausting is that fire damp, dust, and blasting fumes at the face are drawn direct into the duct, and the heading is kept clear for persons working and traveling therein. So, with the exhausting system, the intake air passes slowly along the heading, pick up heat and moisture. If the rock temperature is high, the air arriving at the face will be warm and probably humid. In this condition, forcing ventilation should be employed. So such condition is also you go to the forced system. What is the disadvantage of forced system? The face of the heading will not be ventilated well unless the end of the duct is within very near the face. In exhaust ventilation is employed. This tends to the result high airborne dust concentration at the face of the heading. Emission of gas at the face may not be quickly diluted and dispersed. This is also one disadvantage. This is the overlapping system. So that condition to avoid similar sketch, but addition is there. This is a forcing fan is utilized. In early class, this only this is there. So one is a exhaust tube, two is a heading, third is a exhaust fan, fourth is the blower, and five is the intake. So this is the overlapping exhaust main, overlapping, forcing overlapping system. So with this system, the main duct exhausting air from the heading, but there is a short duct at the at in by end of heading having forcing auxiliary fan and it's out by end. In order to prevent recirculation of air, this auxiliary fan should be sited at least 4 meters out by end of the suction bed. This is very important to where to locate the exhaust fan or where to locate the forcing fan. 4.5 meters out by the end of the suction head is a very important and should have the capacity not exceeding 50% of the airflow entering the end of the suction duct. This system combines many of the advantage of the other system. but it has its own disadvantages. So this method requires two ducts. That is the only important to maintain the and extended, which leads to be extract cost. If the exhaust fan stop and the in-way forcing fan continues to run, a dangerous concentration of fire may build in the face of gas heating. This can be overcome to large extent by interlocking the proper supply to the fans so that uh, if the main auxiliary fan stop in by fan must also be stopped. The overlapping system is particularly suitable for the long wall heatings. There is a very where the suction required for the extra duct can be obtained through the pit ventilation pressure without the use of an auxiliary fan system. Reversible system. This system may be used for the ventilation of sinking shafts. This is very essential for the reversible system, particularly in case of reversible system is required. Within the system of ventilation, there is a single duct having meaning a reversal of airflow in the duct so that the ventilation is either forcing or exhaust. This can be done by number of ways. It is not useful or practical to do so by single fan. However, having either means of reversing the direction of the rotation of the impeller in case of axial flow fan or a system of reversible duct in case of radial flow fan. So since it is not useful possible to sight the fan so that recirculation of air cannot occur, whatever the direction of airflow, the duct, it is therefore necessary to provide a bifurcated duct in the out by end, having a damper each limb so that enable direction of the airflow of the controller is required. So, uh, so this is the one model for the 5 meters away, 4.5 meters sufficient. Similarly, a location installing auxiliary fan locations, mostly 4.5 meters or 5 meters. The location to the intake from the return is also similarly placed, and also intake also similarly placed. Location of installation auxiliary fan. An auxiliary fan should be so installed that there is no possibility of recirculation of the air supplied by is to the working place. The quantity of air taken by the auxiliary fan should not be exceed one third of the quantity of air in the current from the which fan takes its supply. This is a very conditional thing. Otherwise, recirculation of the air is problem is kept. So as per DGMS circular 82, place limit of one third one after current which it has fan taken its air supply. So now the capacity should be one third. The site installation should be at sufficient distance outside the actual heading. It is intended to the ventilate. The forcing fan therefore should be placed on the intake side and auxiliary exhausting fan on the return side of the drift it has to ventilate. And the minimum distance between the fan and the corner of the drift road to be ventilated should be 5 meters as per the shown in above figure concern. Here given this is a figure as per shown. The metallic part of auxiliary fan installing should be earthed to avoid the build of the electrostatic charges which can ignite methane by sparking. The quantity of air to be circulated by an auxiliary fan depending upon the rate of gas emission. The drift roadway and varies from one installation to another. In general term, it may be said that quantity of per minute should be 7 meter cube per meter cube for working phases. In an underground mine, sometimes ventilation will be insufficient in some districts or part of the mine. In such situation, ventilation can be improved by means of auxiliary ventilation. The auxiliary ventilation is possible by use of auxiliary fan and booster fan. The location of booster fan and auxiliary fan important to improve the ventilation and proper precautions have to be taken while installation of the fan. Precautions. Precautions in installation auxiliary fan. All auxiliary fans installation which is drawn in air from an intake airway and feed into the return airway shall be examined once at least in every week by ventilation officer to check that the quantity of air passing in the intake airway on the inlet side of the fan or fan. If more than one fan is drawing air from the same airway, insufficient for the proper ventilation of the indoor working where fans are running. To prevent recirculation of the air, the quantity of air taken by auxiliary fan shall not be exceeded one half of the quantity in the current from which the air passing through the fan is drawn, provided that this rule shall not be applied where the inlet and outlet ends of the ducts are separated by doors or seals. Before an auxiliary fan is installed in the quantity of air, the following airway at the point where it is proposed installed shall be measured to avoid the possibility of recirculation. This is a very important one for the proper ventilation in by district when the fan is running. That is also the both you have to take important. It is if it is necessary to regulate an auxiliary fan, it shall be done such a way to prevent unauthorized or inadequate alternation. Fan delivering air through flexible duct shall not be regulated by the considering a duct. Fan with rigid cut ducting shall not be regulated by placing loose obstructs such as bricks or stone or ducting. So that is also important. No person other than the officers of the ventilation officers, manager or do shall regulate quantity of air passing through the delivery by auxiliary. So it should not be any foreman or something going and simply switch on, switch off, or speed upping of the or installation. This should be authorized by the manager only. In an underground mine, some times ventilation will be insufficient. Some district apart of the mine. In such situation, ventilation can be improved by means of auxiliary ventilation. There may be a method of arranging the. So this is another area again showing here, single heading. Simplest arrangements. This is the actually Indian Labor Organization recommendation of the quantities as per the ILO standards. You can go through it. So ILO quantity is 0.172 per square meter per meter of the drift phase. Extremely hot phase quantity is high as per the drift risk. So CMR actually now 2017 early reports, but old data is given here. Now changes as per the CMR 2019 we had to use what are the quantities going. Similarly, long oscillating a small problem is given, which is related to the duct calculation purpose. Simple problem, Q quantity calculation purpose. Please go through it. Right now, I would like to concluding the summarize the auxiliary system. I hope that you enjoyed today 50 minutes around 60 72 PPTs lecture. I hope that basic purpose of auxiliary ventilation, uh, what is the purpose, basic purpose, and how to, what are the methods for ducting, what is the types of ducts, installation of ducting, uh, and also forced and exhausting of overlapping mechanism, and also standardized as per the without affecting the main fan system. So these are all things are coming to auxiliary ventilation system, but it play a vital role where the particularly in mission mining, particularly when the where is AM50 is working, when the where the road header is working for making of headings, not only just drilling and blasting, and also mechanized also duck is playing a vital role. And moreover, resistance is concerned. It is smooth concern. Uh, more ventilation is possible. So auxiliary ventilation is a very vital role in the playing in the ventilation networking system. I hope that you are understanding all this. I have some prepared some. You have the quiz questions, which is helpful for the competitive examination, ESET examination, and also uh, Coal India or Singer and Police.
JMET examinations also. So, okay, auxiliary fan is a more or less semi-temporary, temporary, permanent, semi-permanent. So you can be say it is purely temporary. It's not a semi-permanent, permanent, semi-permanent. You can say. So you can choose answer which is correct. All auxiliary fans shall be examined once at least in every week, every 15 days, every month, or above. So as per the regulations, you have to answer it. An auxiliary fan shall be examined once at least in how many days? So the distance between the corner of the heading and a place auxiliary fan shall not be less than 4.5, most of 5 meters you have to choose it. Forcing or blowing system is used at wet heading, dry heading, permanent, all the. So that is very important. So some advantage of dry heading will rise. For forced is used for wet heading is suitable. So that is you have to be used. That is a major thing. In exhaust system, the fan is placed in take air, will turn or permanent, all that. Similarly, uh, last quiz question I am going to be giving. Auxiliary fan is more or less. So already I given this one. So not required now. Well, I wish you all the best. Now I'm going to concluding the this auxiliary system. Thank you.